Can you hear me? Working? Excellent. Good. So as you can probably tell, today's presentation is a little bit different from the others. What I'm going to walk you through today is going to be dependent on you, on what you're interested in learning about when it comes to data lakes. So I can cover everything from beginner to intermediate to advanced topics. So I will sort of gauge the audience in a moment to help me cater this presentation. This is about 7 hours of talk track, as you can see on the screen here. There is a lot of detail. So we have got about 7 hours of infographic here that I can walk through. It's all on the topic of data lakes, everything that you see here, except for this little guy over here, which is Spark, if anyone's interested in learning a bit about Spark and how that interfaces with the data lake. So as we're going through this today, guys, yeah, I'd like to have more of a discussion, less of a lecture. So if you do have any questions, please just interrupt, talk over me, raise a hand, just ask a question, okay? Because I do sometimes forget my audience and I might skip ahead on certain acronyms or topics. All right. So yeah, once again, today is around data lakes, best practices, zoning, et cetera, et cetera. And I do have a blueprint that I can go into detail in later, and I probably would like to go into detail in later if we have time, but it will be mainly around best practices. Those of you who have worked with me before, or who know me, know that I've got a lot of insight into what's happening in the Microsoft landscape, which means I will be giving some winks and nudges with respect to some cool stuff coming up. However, I will not break NDA. So if you ever see me emphasize a certain point or look at you emphatically and give you a bit of a wink, you probably want to listen to that because it's going to help you with Azure, Power BI, and data lakes in general. Okay? So let's just dive into this. Bit of an introduction to myself. My name is Simon Nuss. So I'm the VP of Data and Analytics at Hitachi Solutions Canada. I've been doing data warehousing for about 10 years. And more recently, I've been thrust into people leadership positions where I've grown a team of about 50 folk across the Canadian market in the last year. And their focus is Azure Data Engineering and Power BI development. What separates me a little bit, I am a part of the customer advisory board for Microsoft. So that means I help the Power BI team and the Synapse team basically steer product direction. I'm also part of the Enterprise Voice program, which is quite similar as well. And through my organization, which is Hitachi Solutions, I'm a part of the Partner Advisory Council. So suffice to say, all three of these programs give me direct access to what we call the PG, or the product group. I'm on daily calls with the product group where they show me PM art, which is basically fake pictures of features that they want to develop, and they ask me, what do you think of this? So that's sort of my unique sort of pitch and the spiel that and sort of an insight into what I do on a daily basis. All right, I will give you the little spiel on Hitachi Solutions, just because. So we are a consulting company. We are a Microsoft partner, gold partner. We are a part of Hitachi Global, so Hitachi, the big company, one of the largest in the world, and we are the Microsoft subsidiary. So anything that is Microsoft related will go through Hitachi Solutions. So yeah, as I mentioned, my team in particular is data and analytics, so that's everything that's Azure Data Engineering, Power BI development, and data management. But organizationally, we do go a bit beyond just data and analytics, of course. So we have data science, as most people do, custom app dev, cloud migration, and lots of dynamics work as well. So we're one of the, I think, the second or third largest dynamics implementer on the planet. So that's pretty much Hitachi Solutions. We are very big in the States. We haven't really penetrated the Canadian market too much, but that's why they hired me to hire a bunch of people in the last year or so. So I expect to see more of us in the Canadian market when it comes to helping out customers with their data and analytics projects. So I want to, as for the people that's joined, this is a very big presentation. I am going to play it by ear based on the audience. So I'll use this opportunity right now to ask, who here has deployed a data lake before? We've got one person who's good, one person. We've got 1.5 people that have deployed a data lake. Who has used a data lake before or interfaced with a data lake? Okay, about half the audience. Okay, so a couple of developers for data lakes. A couple of half the audience are users of data lakes. Now, who has owned a data lake from an enterprise perspective? Who has managed it for years and seen that evolve over time? Yep, and you were the owner of that, so you had to make decisions on zoning, architecture, deal with departments coming and changing. Okay, good, good. So I'll try to speak to some of that then. So what I'll then do is I'll gear this presentation for a few things. I will talk through this section here, which is basically the history of data warehouses and where data lakes fit into the picture. I will talk about how to zone a data lake at a high level. I think there'll be a lot of value out of that. And I'll probably spend a bit more time on this section here, which is fundamentals or a data lake overview. Okay. I will probably skip this section here, which is when we get into the nitty-gritty of things. In particular, something called ACLs, which I will avoid for today, I think. It's a topic that's a little too complex. And I will probably round out the discussion with walking you through in about 5 or 10 minutes how to zone a data lake and how to structure a data lake such that it is future-proofed, which is very important. So I will not talk about the compute that connects to a data lake, and I will not talk about Spark. But if anyone has any questions on that, feel free to reach out and ask at the end of this presentation. So let's go all the way back to the beginning here. So data warehousing. This is from a very famous paper from Databricks in 2020, 2021, basically talking about how they view the world in terms of data warehouses. And they view it in 3 components. The one on the left here, that is our data warehouse that's usually on premise using SSIS. So that is taking a data source, transforming the data in transit and loading it to a data warehouse. And it's all well and good. That's what we've been doing for 30 to 40 years. Where we are right now is tier 2 architectures, or 2-tier architectures, I should say. That's the one in the middle. This is that modern data estate that's been pushed by Microsoft the last few years, right? So we have introduced a data lake now. So as you can see, there is a data lake in this design for a data warehouse. But aside from that, it's basically exactly the same as this. So I like to joke that a 2-tier architecture, which is mostly where we're at now, is exactly the same as the architecture we did 30 years ago, but with more work because we've just inserted a data lake. The reason why we do that, of course, is that it unlocks new use cases. We have access to unstructured or semi-structured data. So files, JPEGs, WAV files, videos, et cetera, et cetera. Obviously, you can't store those in a data warehouse and do much insightful analytics on it. So this sort of introduction of a data lake unlocks machine learning. Okay. And where the world is kind of at now, but definitely moving towards, is something called lakehouse architecture. And this is one of those winky moments that I'm going to say, I won't break NDA, but I can say lakehouse architecture. That's something you want to research. Lakehouse architecture is really where the industry is headed, if you're a Databricks shop especially. And I like to sort of compare the differences between where we're mostly at now to where we're going, and I like to say it as this. Where we're at right now, we load data to a data lake, then we take that data, I'll mix it into the conversation. We take that data and then we move it into something like a dedicated SQL pool. And the second you do that, there's a bit of a problem. First and foremost, it's out of sync with the data lake, and the data's stale, and you basically are locked into a proprietary engine, right? So that's sort of the problem with what we're doing right now for the most part. Now, I would say that that's quite simply, we take our data and we move it to the compute. That's how I summarize where we are now. We take our data and we move it to the compute. Conversely, this is what Lakehouse is. So Lakehouse, we take the compute and we move it to the data. So let's say that again. Where we are now, we take data, we move it into the compute, and it's stale. Lakehouse, we don't. The data stays where it is in your data lake, and then we move any piece of compute you want to the data. And that's very important because it means that we're not locked into a proprietary engine. It means that when we access that data lake layer, it's as real time as possible. It's the latest snapshot of data. Okay. So I want to pause there for a moment. Any questions on the differences between basically where we are now and where we're going with the lakehouse architecture? Nope. Everybody's an expert? Good. All right. I'm not going to spend too much time on this, but I've basically taken those 3 components and broken them out into what we see here in their Azure components. So quick example here. This is our first generation. We have a SSIS or data factory. We do ETL in transit and load it to a data warehouse. The big problem with that is that we can't replay the data warehouse. So say, for example, someone goes in here and deletes the whole damn thing and you don't have a backup, you're in trouble because there's no storage of data. There's no historical storage of that data in the data lake. This is that second generation. We have a data lake in the picture now. So what this allows us to do is that now we can, quite simply, if we still have a dedicated sort of SQL pool here, for example, batch data warehouse. In this example here, obviously if someone deletes our data warehouse or our slowly changing dimensions get deleted and there is no backup, it's no problem, right? Because we know that all the data landed here and still exists in there. So we can regenerate that data warehouse. And that's the benefit of where we're at right now. And last, we have our lakehouse design. And so this is, in my opinion, quite beautiful. I really do love this. But yeah, what we can see here is that everything is landing into the data lake, and that is the end of the line for all data, period, end of story. No data goes past that point except for in the result set of a query. Okay? So no data goes beyond this point except for in the result set of a query. That query could be T-SQL, Spark SQL, DAX, M, you name it. And that's why we say BYOC, bring your own compute. It shouldn't matter what tool you want to use as a developer. It shouldn't matter what language you want to use as a developer. Those things should be up to the developer, not the architecture. Right? And that's what Lakehouse gives you. You can bring your data to the compute. So that's basically your Lakehouse design. All right. So with that said, that's sort of the history of data warehousing that we have. Now let's dive into the topic of data lakes, which is mainly the topic for today. Any questions on that, though? I'll pause again. Any questions on the history of data warehouses and Lakehouse in general? Yeah? So jQuery. And Lakehouse is designed for real time. Okay, so you're not moving data into a separate piece of proprietary compute. So when you ping that, when you hit that data lake, it's data as fresh as it could be in that data lake. Okay. So let's skip this one for a second. What is a data lake? A data lake is literally nothing more than files and folders. And if anyone tells you anything else, they're a bloody liar. Literally, and this is, I have so much trouble really communicating this to people because people have this massive image in their head of this amazing thing called a data lake, and oh, you can't touch it. It's this ephemeral thing that just exists out there in the ether. It's not. It's literally just files and folders. End of story. Period. Nothing more than files and folders. Okay, everyone's got that in their heads. Right. So don't think of a data lake as anything more than that, please. The analogy I like to give is that, especially for people who are on-premise or who are familiar with a PC, you can think of a data lake as your hard drive. Okay, and in your hard drive, you have A drive, C drive, B drive. Those are what we call containers. Okay, so this whole box would be your hard drive, and this might be C drive for argument's sake, or D drive. And we call those containers in data lake nomenclature. And exactly like your hard drive, once you have C drive, you can just right-click and make a new folder. That's it, nothing more. So that's your data lake. So you might think, oh, that's simple, but just be aware that we've dealt with network files or network drives our whole career, haven't we? Everyone's in the last 10, 20 years, you've logged into a network drive at your company, and what have you seen? Frankly, a complete shit show. That's what you see. You see folders everywhere, projects, people name, departments, all mixed up, different access permissions. It's very hard to manage over time. And so when you get to data lakes, you have the exact same issue. And that's why I'll be walking through how do you zone a data lake to future-proof it. Much like you should future-proof a network drive in the old days, you should also future-proof a data lake as well. So I will walk through that and sort of the design implications of certain decisions that you need to make, okay? So since most people in this room, when I took a survey, are quite new to data lakes, I will walk through sort of this overview slide here. I didn't plan to give any demos today. I mean, I do have these little demo sections. I didn't plan to do that. For those of you who have just joined, this is a part of about 7 hours of walkthrough. So everyone's aware, we've got a lot more people in the room. This is about 7 hours of walkthrough right here. So I'm just going to go through and really speak to what you see on the screen here. I won't be giving a demo or anything. So first and foremost, a data lake. It's an Azure resource. You need a subscription, you need a resource group. Once you have your data lake installed, there is something special you need to, well, once you have your storage account installed, there is something special that you need to do, and you need to tick a tick box called hierarchical namespace. Okay, so when you install this resource in Azure, tick that tick box, and that magically turns it into a data lake. If anyone's curious, hierarchical namespace basically has sort of performance implications behind it. So when you tick that tick box, there is performance benefits of accessing certain files or groups of files when you tick that tick box. In your storage account, in that second bullet point here, let me zoom in a bit. In that storage account, there's lots of different things that a storage account can do. In fact, we can even do FTP now as well, SFTP. But you've got blob, file share, queue, and table. When we talk about data lakes, it is just blob storage. So ignore file share, queues, tables. Those have nothing to do with the data lake. We're only focusing on one big part, one tiny part of the broader storage account, and that is blob storage. Okay? And that is what you see in this picture here of files and folders. Okay? When you access the data lake, there is, oh God, like 30 endpoints, like 10 endpoints at least, that you can use to access the data lake in theory, but this is the one you want to use for most tools. So DFS is what you're looking for. If you try to use anything else for most client tools, it won't work. So storage account name could be my data lake, dfs.quarterwindows.net, and then we go to the containers and of what that picture was up above, right? So the container, which is like C drive, and then all your folders and files that go after that. Just be aware that this hierarchical namespace thing that I spoke about, once you click that tick box, you will lose some features that exist right now in blob storage. So it is not a feature parity, or it's actually getting pretty darn close right now, but there are some features that don't quite exist. So next I'll go through and talk about a few extra things to be aware of in a data lake. But are there any questions at a high level on the overview? Any questions on the high level of a data lake? Nope. All right. So some other considerations when setting up or installing a data lake. There are performance tiers. First and foremost, when you do install a data lake, during that process, you have an option to select premium. Premium are basically, they're not spinning disks, they're like SSDs. Okay, so when you select premium, it's going to be much quicker. Okay. We have, once you move beyond that point and you're looking at the files and the folders themselves within the data lake, you've got three settings, I guess you can call them archive tiers for files and folders. Hot is what you want for your gold and silver zones, which I'll talk about in a moment. And that is the fastest. So when people query that, they're going to get the most amount of data as fast as possible. Then you have cold storage, which you can save a bit of money if you have cold storage, but your queries go a little bit slower. And then you have archive. And so archive, you save a lot of money with storage, but unfortunately you can't even access your own data. You have to think of it like a physical box of files. You have to request access to the box, and then a day or two later, you get access to it. Consider archive very much like that. A question? Yes. You can, but what you want to do is really look beyond that. You want to go and examine each individual part of your data lake. And I'll get into zoning parts of a data lake, bronze, silver, gold shortly. But you can set up what it should be for the account for the most part in terms of a default, but you really want to peel it apart. You want to have a look at each part individually and ask what is the best setting to have. I might use this moment then to talk about what's called the medallion architecture. Okay, for those of you who have used data lakes, you might have heard of the medallion architecture, and that is zones, bronze, silver, and gold. This is really no different than like landing, curation, presentation, transformation stages that you see in a data warehouse. It's just that Databricks has mainly pushed this nomenclature, and so when you set up the folders in your data lake, like you physically organize your folders, when you set that up, we generally say it's going to be a medallion architecture, and we set up bronze, silver, and gold. The reason why we say bronze, silver, and gold is that if you go out into the industry right now and you ask people how they set up their data warehouses, you're going to get 10 different answers. You're going to get your raw area, your staging area, your cleansed data area, your presentation area. Like everyone's got so many names right now, but bronze, silver, and gold is very consistent. It's very clean. Which begs the question though, what does bronze, silver, and gold even mean? And you will get different answers based on different people. I will give you my definition based on a lot of experience, okay? But basically, high level, everyone agrees that bronze is raw data. So data as is from the source. JSON if it's an API, a WAV file if it's audio, right? So that's what bronze is. Silver is like going to a restaurant. It's a silver platter. It's unaggregated, unfiltered data. Sometimes it has some calculations in it, but it's largely there. So your first point of interjection for people from the data scientists and data engineers to access and do analytics on. And that last layer called gold, that is basically the area where it's gold. You unlock business value. There's money behind it. So that's where you have the results of machine learning algorithms. You have maybe your semantic layer as much as possible stored inside that gold area. So that's where business users would largely interface with the data lake. Yeah. But I'll go into more detail when I walk through that whole architecture. This is just a small table that sort of summarizes everything I said above, kind of the benefits and pros and cons between each of those performance tiers of files and folders. Next thing to be aware of, lifecycle management. You can, and by the way, I'm not sure if this is in preview anymore. That might be out of date. This presentation is about 6 months old, but there is some tiering that you can do for automatically adjusting certain things within your data lake. It's largely around date last modified, date created, date last access, all that sort of good stuff. And we've just got some examples here. So transition files from cool to hot immediately have access to optimize performance. Makes sense, right? If people are accessing files in the data lake, you want those probably to be hot. Okay. Transition blobs, blob versions, so on and so forth. There's lots of different options for automating everything we've discussed in this section, okay? You'll note, though, that we don't automate premium. That is more of a setting for your storage account. It is not a setting for files and folders. Okay. All right. So I will go in and talk about a little bit around this. But are there any questions on, I guess, performance of files and folders in the data lake so far? Any questions on anything we've covered in the last 5 or 10 minutes? So I won't spend much time on this because frankly, most people find it boring. We're more interested in the analytics and not the infrastructure side of things. But when you set up your data lake, you can set up all sorts of different ways to zone that data, or sorry, to geolocate that data or spread it across a geographical region. Long story short, and I will share this, by the way, with you later so you can read all the text here. But long story short, you've got your primary region, your secondary region. So for redundancy, you can have a secondary region. Within each region, you have something called an availability zone. Some of us might be aware of that. So say, for example, Central Canada would be the region. And I think Central Canada's got 3 or 4 availability zones. So there's a physical data center spread across, like physically across Central Canada, okay? We need to be aware of that, like what those mean, in order to best select how you're going to spread your data geographically. And of course, the reason why we do all this, of course, is if Microsoft's data center explodes. That's basically it. You don't get a lot of benefits from a functionality perspective per se. Accessing some of the secondary regions can be challenging depending on which ones that you select. For example, here, cannot read or write in the secondary region unless there's a failover. So just be aware that there's not a lot of like benefit from a functional perspective that you get out of this. Well, as I said, this is the more boring infrastructure stuff. So I won't go into too much detail on that. I think this is the last section for our introduction to data lakes. Monitoring. So obviously having a big data lake in an organization, you need to be aware of what's happening inside of it because it can help with costs and it can help manage complexity of what's happening within that data lake. So there's a few things that we can do. Come in GA about a year ago is a feature to automatically do an inventory of your data lake. Okay, so for example, every single night, this can kick off and literally catalog the metadata for every file and folder in your data lake and save it back into your data lake as a CSV file or a Parquet file. And then you can plug Power BI into that. And then you can do things like, how many files do I have in my data lake? How many gigs do I have in a data lake? How is that spread across the different zones? So very, very useful to set that up. You do have the ability somewhat to do that in Purview. Ian, actually, do you want to take 10 seconds and talk about what Purview can do with a data lake to throw you on the spot? Yep, so data access policies, which I did want to leave out of scope for this presentation, but data access policies will be soon available in Purview. For those of you who don't know Ian or haven't seen his presentations, he's not presenting today, but he has presented a lot on the topic of Purview. Probably, in my opinion, the leading expert of Purview in Canada. So if you have any questions for Purview, reach out to that guy. And we have logging as well. So there is now a more advanced way of doing this. This is a bit out of date, but you can get access to more information than you see up here with data lakes. For example, who is accessing files? When are they accessing those files? All of that good auditing stuff. All right. So I think I've covered pretty much all the main features of a data lake. To cover it all off very briefly, it's files and folders. That's a data lake. If anyone tells you anything more, they're literally lying. It's just files and folders. And yeah, and you have all those other considerations from geo-redundancy and some performance decisions to make around how you set up your access tiers. All right, any questions on that so far, or are we all data lake experts? Everyone's going to pass the test? Good. All right, so this is that point in the discussion. Guys, I'm going to leave it up to you on where you want this to go. I do want to go through that blue section, and this will walk you through some of the design decisions you need to make around a data lake and what I think is best. Or we can go through more of a deep dive on security around a data lake and accessing a data lake. So I'll put the question out there. Who's interested in the security side of things? Okay, all right. It's more than I expected, actually. And who's interested in, obviously, the zoning and the blueprinting and everything? Good. All right. Okay, so I'll definitely go through that blue section then. How much time do I have left? Where are we? I don't know. Oh, there we go. So till 12:40, I guess I've got. Is that right? All right, we've got plenty of time. So about 20 minutes. So, and we as I said, we're not going to go through Spark. Spark is something that's way out of scope for this, but I will go through that later if you want after this presentation. So, you know what, let me just go quickly into this section. There's a few things I want to talk about here because there are some best practices in this section here. Some of them relate to security, obviously. This is a security section, but there are some things in this section here I want to highlight. First and foremost, I have something called a reasonably flat design. So when you make your data lakes, do not create hierarchies of highly nested stuff. Avoid that like the plague. Unfortunately, that's what I see 99% of the time. So every customer that I go to, I will go into the data lake and I'll see like 10 layers deep of files and folders by department, by project name, by people's name. Never, ever, 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 ever do that. Keep your data lake reasonably flat. So what does that mean? Use containers. Remember like C drive, D drive, that's a container. Use your containers, they're there to be used. Literally probably 80% of every single customer I go into, I load up the data lake, I see 1 or 2 containers, maybe 3 or 4 if I'm lucky. And I ask the question, how many data sources do you have? Oh, 20 or 30. Like you have 20 or 30 data sources flowing into that container. That is not a good design. That's what we call a monolithic design. Everything is not decoupled. Everything is smooshed together into one folder or container somewhere. So please avoid that. So that's that. I won't go into the topic of data mesh, but data mesh speaks to compartmentalizing monolithic architectures. And that's what I'm talking about here, okay? Please, yes. Yeah, so it was released in 2019, April, I think. Didn't get a lot of traction because physically no one knew how to actually implement it. It's built upon 4 principles. Long story short, it's looking at, as I said, compartmentalizing monolithic architectures, treating data as a product. So that means actually have product teams around data. Advertise it, get champions around it, push it out in the organization, decentralizing governance. So set up guardrails for an organization, but then letting people do their own damn thing. And then you've got to have an environment that would support all of this and the governance to enact it. So long story short, I love the idea. I think it's a fantastic idea. Data mesh is amazing. It is the future. Technically speaking, as a Microsoft shop, we're not there yet. There is something called cloud scale analytics, which is part of the, sits on top of the WAF and the CAF, if you guys are familiar with that. And that seeks to roll out data mesh at an organization. It gives you the architecture. So cloud scale analytics gives you the architecture to roll out data mesh. So have a look into cloud scale analytics if you're interested. But long story short, you still need someone to implement it. You still need to set up the policies because Azure is a PaaS service, right? It's platform as a service, which means it just doesn't magically work. You need to implement cloud scale analytics to get even data mesh working. So I love the idea. Technically speaking, it's an Azure shop. Because we use PaaS for most of our analytics, data mesh is very hard to implement. That's the unfortunate truth. However, if we were to go to SaaS, for example, so say for example, Power BI's got data marts, right? We can see that obviously Power BI is growing its capabilities. And just imagine if there were more capabilities in Power BI, you would see that data mesh coming into reality because it's a SaaS platform. Data marts are in there. Just imagine if Spark or something else was in there. You'd have all of your DNA tools within a platform that's SaaS. And when you do that, then you can enable data mesh because there's no way to escape it. Right now in Azure, I can escape data mesh. Doesn't matter what my policy is, I could probably spin up a subscription and work my way around it. So that's my big rant on data mesh. Yeah, so I'll avoid security. So once again, before I go into that, I did miss a section. So before I go into that massive zoning thing, I do want to talk about data lake examples. And that's not centered. There we go. Data lake examples. This is what I see in most organizations. Don't do this. Container, bronze, data sources mixed together in that folder. Never, ever, 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 ever do that. The large majority of customers that I come across, they do this. for one reason and one reason only. They install that data lake for a data warehouse. Data lake is not for a data warehouse. Okay, so they go, oh, we need a data warehouse. We want it to be two-tier or lakehouse, so we're going to install a data lake. And so they're using that data lake with the data warehouse mindset, which means they're jamming everything together. A data lake is just a means to an end to get to a data warehouse. And that's what you get. The problem with this is that data warehouses are temporary. They last 5, 10, 15, 20 years. So with that in mind, your data lake should last longer than that. So how do you structure your data lake such that it's not a function of a project? Data warehouse is a project. Right? So we've structured this to meet the need of today's data warehouse. But when or if that data warehouse explodes, or maybe the team managing this data source gets moved to another department than the team managing this data source, it's a bit of a problem because now you've got it all mixed together. Okay, so that's a bad design. And I see that the majority of time with customers don't do that. But what can you do? Here's sort of the next step along this process. You have one container still, but split out your data sources. That way the team managing this data source needs to get moved around or there's a reorg, right? It's decoupled. I know it's a very simple change, but it's decoupled. This will stand the test of time a lot longer than this architecture here. 2 ticks, which means it must be better. Use containers. Have your data sources flowing into your data lake as containers. Okay, separate containers, completely and utterly separate. Once again, you know, if you bring a consultant in, it's very easy to grant him access. In fact, I don't even need ACLs for this. Teams move around. There's a reorg, right? Doesn't matter. Everything's compartmentalized. It's very easy to manage this. And this one here is interesting and a spicy topic. Multiple data lakes. I've spent 7 years of my career deploying and owning data lakes. And for the past, with the exception of the past year, I've said you have to have an enterprise data lake. You have to. It has to be one data lake. And all the departments, all the domains in one organization flow into one data lake. You know, at most I might give it up and say, okay, well, you can have 2 or 3 data lakes, but no more. Here's my spicy suggestion. That doesn't matter anymore. And this is one of those winky moments that some people are probably wondering what I'm talking about. That won't matter anymore. So think about hard drives, right? We have one hard drive, C drive, files and folders. What happened with that over time? We got RAID arrays. What's a RAID array? Virtualization of hard drives. So I'll leave it at that. So connect the dots, but don't be afraid doing this. In fact, I'd almost even suggest it. Don't be afraid to make data lakes anymore. And that's an incredibly uncomfortable topic for many people in this room. But get used to it because you have no choice. Yes? I need to be careful how I answer this. I would flip that and say, what's the benefit of having it all together? So I'd take your question, reverse it, and throw it back at you. What's the benefit of having one data lake? Yeah. So it's future proofing, right? It's compartmentalizing things. Organizations change. They get reorged. Projects come and go. Data sources come and go. So the further you can separate things, the more it'll stand the test of time. That's ultimately it, and that's what we're seeing in the progression here. We're seeing monolithic to compartmentalized. In fact, this could even be GCP or AWS, right? Yeah. Yeah, why not? I mean, we wanted to be Azure, of course, but you know, that's the way things go. So yeah, don't be afraid to do compartmentalize things more than we traditionally have. This is the current model, right? No one does this right now, within reason. And to consume eventually at the business layer or core layer, it becomes hard because then there has to be some kind of a data mart where things get merged. Yes and no. Remember Lakehouse architecture, where the world is going to. That's all about bringing your computer to the data lake. And sorry, the question was, I guess maybe I can summarize. It was a question sort of, do we need to even have people accessing the data lake, or should they go through a data mart to access the data lake? Yeah. So the answer to that question is, Lakehouse, it shouldn't matter what your piece of compute is. There doesn't need to be a data mart. There doesn't need to be serverless, Spark, Custo. There doesn't need to be any of that. If you have a very well-constructed data lake that's compartmentalized, Bring your own compute. You got it. So you don't want to constrict your developers to something some guy's vision 5 years ago, right? That's the point of all this. Yep. Yes. And I'll get into that. How much time? So I've got 15 minutes left, I think. I go to 12:40. So I'll jump to the flow, the big diagram in a couple of minutes. That'll speak to some of that. But you didn't ask it, but you raise a valid problem with this approach, and that is governance. If you have multiple data lakes, how do you make sure they have the same settings, that you're applying the same policies, that people are using them in the same fashion? That is true. Governance is much harder, and that touches on the whole topic of data mesh. But yeah, it's pros and cons. It's harder to govern, but everything's come up more compartmentalized and future-proofed. And I'm actually, if you paid close attention here, you might actually notice something interesting about what I've written here. These are data source containers. This is a data product container. Data sources can be considered data products, but putting that aside, that's a very important distinction. And I'll actually speak to here because I'm about to dive into it in much more detail. So I'll speak to it here at a high level. When you bring data into a data lake, and this is from someone who's owned data lakes for a long period of time, keep your inflow of your data source completely and utterly, completely separate from any project that you have. Projects are point in time. Projects last a couple of years. But a data source is always a data source. It doesn't matter if that data source's company gets acquired and the name changes. It doesn't matter if tables get renamed and columns dropped or whatever. That is always true. A data source is always literally a data source. So never ever bring a project into this section. Let's pretend it's Dynamics 365 CE or something. This is Dynamics flowing in. Have a data lake for that, or a container just for that one data source. You also might note there's no gold here, right? If I'm bringing in a data source, I'm going to have the raw data here, like CDM folder format, if it's Synapse Link. Here I might have Delta Lake or Parquet, right? I don't necessarily, because this is a data source, this is a representation of a data source. I don't necessarily need a gold folder. Remember, gold is like the ML. Gold is like the star schema, right? If I'm just serving up on a silver platter the data source as is, I'm probably going to stop at silver. So very, very important. If you're going to take one thing away today, that's it. All right, let's dive into it. So I've got 10 minutes. So there were two types of containers, a data source container, which is just serving that data source. There's no analytics in there. It represents the essence of that data source and nothing else in the story. There was that second container called a data product container. That's the answer. That's the answer to your question. So a data product container could be a project container or a person container or a department or a team container. It's something that could and probably would bring in multiple other data sources. When you appreciate, I want to drive that point through for the third or fourth time. Two types of containers: data source container. It just has stuff for that data source and literally nothing else. And then you have a second type of container, which is more your data product or data project container, right? That could be a person who wants a container on a data lake, or a project. Obviously, data warehouse is nothing but a project, right? Kind of. It's more of a product, but so that you keep it separate. And so with this in mind, you have, to get more data meshy, you would have all these data source containers, which would be as true to the application that's generating that data, and you'd have data owners around that. You treat that like a data product. And then this data warehouse, it doesn't pull from anywhere else. It doesn't pull from a third-party system. It doesn't pull from a SQL server. It's just pulling from other parts of your data lake. And with that in mind, it's really quite beautiful because there is now no reliance for this data warehouse project or team to go to an application to even get access to it. They're just pulling literally from other parts of the data lake. That's very elegant, very succinct, scoped incredibly well. But anyway, let's dive into it. We've got 10 minutes, I think. So what I'm going to walk you through in 10 minutes is all of this. I will talk about bronze, silver, and gold, some pros and cons of each. And so here we go, silver, for example. And I'll also talk about those two container types, right? So I'll talk about that data source container and the data product container, for lack of a better word. There is a section over here on the right, which I'll briefly talk to, which is just some examples of different types of compute, but that's more of a means to the end, that section on the right. Our main discussion is here on the left. So before I dive into the details, any questions on anything I've covered so far? Nope. All right. So for those of you who joined late, I've owned data lakes for many, many years. I've gone through the trials and tribulations of departments, merging, teams changing, people getting fired and terminated. You will not find this level of detail online. In fact, most of the data lake stuff that you find online are from people who are consultants. They've deployed data lakes and said, see you later, client. And then 2-3 years later, the whole thing's a complete data swamp. What I'm walking you through now is a future-proof design. Right? This is something that I've gone through many, many times, and this is future-proofed, and that's a bold claim to make. So let's walk through it. We're going to begin by a data source container. And in this example, I think it's a POS system, which is point of sale, by the way. It's a point of sale system. So like, you know, you go to a Domino's or like a convenience store or something, and they put in the items. Kimball would say, Ralph Kimball, who makes data warehouses, would say it's kind of like the beep of the application. That's what this is. Okay. And because this is a data source container, we're only, in this example here, we're only going to go to bronze and silver, okay? We're just going to talk about bronze and silver. So let's dive into it. We're going to follow the journey of a sales table. This is one table of data called sales, for argument's sake. So before I sort of talk to that yellow box, let's walk through the journey. So we have a table called sales inside our bronze container, inside a folder called bronze. Snowflake means it's cold. We're saving money on this storage account. Oh, sorry. We're saving money on this file, or this folder, sorry, because it's set to cold tier, okay? We have that table going in 3 different places. Very first and foremost, it goes in the in folder. This is where it first lands, when it first enters your data lake. And this example here is probably from an API, so we're landing it as type JSON. Okay? And this point here, we need to do a schema check in our bronze zone. This is something that people have different opinions on. I'm very much a fan of doing a schema check in my bronze zone. I'll tell you why in a second. So if it passes the schema check, it's going to go to an out folder, which I'll talk about in a moment. If it fails the schema check, it goes to a bad folder. So say, for example, it's malformed or corrupted, right? You want to physically move, cut and paste that file to a bad folder. And here's the reason why. If you have bad data up there, guess what's going to happen? Your data scientists are going to get access to the bronze layer. They're going to query that folder, error messages. So anything that does not pass the schema check, you physically have to move to a separate location. Not many customers do this. But as soon as the data scientists get access to that bronze layer, they spend like 3 months trying to fix it up. So get to it in the beginning, do a schema check in your bronze layer, okay? And then move the files so you've got clean data and crappy data. In this example here, and this is optional, it's passed our schema check, and I'm still keeping it in the bronze area. I'm just merging it into an aggregated file. So I have Parquet in this example, and this is optional. I have Parquet in my bronze layer, and I'm actually taking, for example, this is the whole day. This is a whole day of JSON files that are streaming through in seconds, right? I'm just merging those into my bronze layer into a daily snapshot called sales.parquet. And you know, after a day of running this, like running a pipeline through your data lake, this would have all the sales for that one day, 31st of December. So that's the end of the bronze area. Kimball has something, Kimball makes, you know, famous for data warehouses. He's got something called the back room. This is the back room. Limit access to the bronze area, okay? Only give access to data engineers and maybe data scientists. Definitely not business users, definitely not data analysts, okay? It's void of SLA. If your data scientist is using it, just say, look, you know, things could break. Yeah, I wouldn't say void, but you know, it shouldn't have many SLAs around it, right? It's the back room. And very important, we decentralize everything. So what I'm saying here is we don't want data scientists setting up automated pipelines from the bronze area for the most part. They can do it, but it's extremely rare. It should be only the data engineer that sets up these pipelines for the most part. Yeah, I'll ignore that for now. We've only got 5 minutes left. So that sort of ends the bronze area. So to summarize, it's your raw data such that everything's cleaned up. So I can hit F5 on my query on this folder and pass all the JSON files. Are there any questions on the bronze layer before I move into the silver one? Yes. Good point. Good point. So this is this is a topic that I won't cover today, but it's called partitioning. So especially when you have things like Parquet files, in this case it's a JSON file, partitioning is the act of separating that file into effectively folders. Sometimes you partition files when it's a file type called a Parquet. But the reason why we do this is for query performance, basically. So when I run when I hit F5 to query this folder, it'll just query all the files underneath it. If I hit F5 on this, just the files underneath it. Conversely, if we have this completely flat to this point here, if I hit F5 on that, it's going to have to do a scan. Somewhere there's going to be some piece of compute that needs to scan potentially millions or billions of these for a whole year before you can get your result back. So that's performance, I should say. This is partitioning for performance. Okay. So once we go through that bronze layer, we have silver. Silver is very simple. Silver should be unfiltered as much as possible. It should be unaggregated as much as possible. It should be as reflective of the source system as much as possible. Okay. The reason why is that this is sort of the first injection point into your data lake for most people, for a lot of people. Okay. So yes, this is when you do have SLA set up. Data quality should have definitely been done at this point because people are accessing this, running their queries off it. In this example, I don't have a gold folder, but consider it in some scenarios. For example, enterprise-wide semantics. Say, for example, you're in a dynamic system and someone wants to add a column to it that is a sum of their birthday plus another column. I'm going to be like, well, go away. But if they come and say, well, I want you to add to the dynamics data source a column that anyone in the organization will find value from, in that case, I will be, sure, why not? Since everyone's going to get value of me adding a column here, for example, that could be an example of adding a bronze layer, right? Because we're not editing, but we're adding something beyond the true essence of the application. So that would call for a gold layer. And performance issues as well. So when you get to big data, if we just have this sales table, it could be very, very big. It could be gigabytes, petabytes, whatever, right? In that scenario, yeah, you may want to aggregate it, or you may want to filter it. And that is another scenario where that would justify having a gold folder or a gold container here. So yeah, in this example, though, I do have 3 types of data. I'm going to cross this guy out. Let's not focus on CD and folder format anymore. It's, yep. CSV, have CSV. A lot of systems can access this and cannot access this. They're basically the same data, by the way. So like if I query this and I query that, I would expect to see the same data. But not all systems support Parquet. Well, this is actually Delta. The icon's type Delta. But, so yeah, try to have 2 copies where possible. One that's more open, like a CSV, and one that's slightly more closed source, even though it's open now, type Delta. Okay. They're exactly the same data, just servicing different customers. 2 minutes left. So, which begs the question of what do we do for a project like a data warehouse? Well, very simply, we can use a piece of compute. Not going to go into detail, but we could use Spark, for example, which you should probably look into using. And then here is a data warehouse container or a project container or a data product container. I call it a data product container. So here we have data warehouse. You'll note that there's no bronze, silver, gold here. There could be, right? There could be. I just don't have it in this example. You have to think though that all the data that this data warehouse is pulling from is from the data lake. So it's already gone through data quality. It's already gone through some cleaning. So in this data product container, you may not even consider bronze because there's no raw data. There's no raw data landing in here. It's just reading from silver containers in the other parts of the data lake. And I won't talk through the structure, but yeah, I mean, example, source system, fact, tables, file types. It is what it is. But a few things to highlight here. Oh, yeah, could be a person, a project, a team, a department. In this case, it's a project called Data Warehouse. Yeah, it will pull from multiple other data sources in that same data lake. Maybe pull from an external system, although you should probably avoid that, right? If your data warehouse needs to pull from an external system that's not in your data lake, that would justify making a data source container. Yeah, full agency is given to the person who owns that to break it, right? As they should. People should have their own part of the data lake to do what they want and make a mess of it. And the best part is your data source is separate. Once again, compartmentalization. It doesn't matter if they break this section. Yep, and since someone else owns it, who's probably not a centralized IT team, you need to provide guardrails. So set up cost alerts, inventory, some of those other things that I discussed. Help them out a little bit. Set some guardrails so they don't charge the department $1 million a month. So guys, we're at time now. That's pretty much everything for a data lake. Some things just to quickly wrap it up. Don't be afraid of making multiple data lakes anymore. Well, today, but very soon, don't worry about it. Try to have a relatively flat architecture, ignore partitioning aside. You don't want to have things by department in your data lake. You don't want to have things by project or person, because when those things change over time, remember. So anytime you have something by project or person, have a separate container, right? Yeah, I think that's pretty much it, guys. Any questions? Well, I'll be here for a few minutes. Well, thank you very much, guys. Hope you enjoyed it. Yep. If there's any questions, come up. I can also share this after the presentation as well if you're interested.